Hello guys, welcome back to the channel, and today we are going to see kernel trick in support vector machine. So support vector machine, that is SVM, are used for classification, and the kernel trick makes SVMs more effective on non-linear data. Kernel trick transforms data into higher dimensional space. Then the transformation uses a mathematical function called kernel, and this helps SVM draw a dividing line or hyperplane in complex data. Linear versus non-linear problems that can be solved by kernel tricks. SVM works well with linearly separable data, and real world data is often non-linear, so we can't separate it easily with a straight line. Therefore, the kernel trick helps tackle this issue by enabling non-linear classification. Now we'll see feature mapping. To handle non-linear data, SVM map data into a higher dimensional space where separation is easier. Example, moving data from 2D to 3D might make it easier to split data. Now we'll see the types of kernel functions. First is linear kernel. No transformations works well for linearly separable data. Second is polynomial kernel. Adds polynomial features, captures interactions. Third is radial basis function kernel, RBF. It uses distance for complex data patterns. And fourth is sigmoid kernel. It acts like a neural network with sigmoid functions. With the help of these diagrams, we can see how we can apply the kernel trick on non-linearly separable data to make it linearly separable. In first diagram, we have a 2D figure which represents x and y axis, and after applying the kernel trick we can see it in 3D three-dimensional state, that is x, y and z axis. So now we'll see how does the kernel trick work. The kernel trick relies on inner products, that is dot product of vectors. SVM relies decision on these dot products in input space. Kernel functions substitute dot products with calculations in higher dimensions, and this approach saves time by avoiding direct coordinate calculations. The formula for kernel trick is k of xy is equal to phi of x dot phi of y, where x and y represents input vectors and phi represents a mapping function to higher dimensional space. So this was it for the kernel trick in support vector machine, and if you found this video helpful, please don't forget to like, share and subscribe to the channel, and thank you for watching till here.